but we're going to do this. And in this particular instance, this is an ellipse, and you're going to say, how do I know? A and B, this is a squared, this is b squared. A squared and b squared are different numbers. If these were both 9s, it would be a circle. If these were both 16s, it would be a circle. Because these are different, it's an ellipse. What's the center? 0, 0. Technically speaking, this is x minus 0 squared, and technically speaking, this is y minus 0 squared. So the center is 0, 0. A happens to be the square root, the thing that's under x squared, which is the square root of 9, which is 3. And B is the square root of 16, which is 4. I don't care whether the A is under the x squared or whether the B is under the y squared. I just need to know who is associated with. If it's under the x squared, it's associated with x. Under the y squared, it's associated with y. This would be the distance from center this direction because it's under the x. This is the distance from center this direction because it's under the y. That's all I need to concern myself with. What are the x-intercepts? Well, we really don't need them, but we're going to do them anyway. X-intercepts, if they exist, well, x-intercept means that y is 0. So you're going to get x squared over 9 plus 0 squared over 16 equals 1. X squared over 9 equals 1. Multiply through by 9. X squared equals 9, or x is plus or minus the square root of 9, which is plus or minus 3. So I'm going to have plus or minus 3, 0. Y-intercept is where x equals 0. So I'd have 0 squared over 9 plus y squared over 16 equals 1. Y squared over 16 equals 1. Clear the fraction. So y squared equals 16, or y is plus or minus the square root of 16, which is 4. So it's plus or minus, what's 0, plus or minus 4. And I can plot those if I like. I'm going to get them anyway. So essentially, how do I do an ellipse? Well, the first thing I put in is the center. The center is at 0, 0. The 9 is under the x. So that says I am going to go 3 units to the left and right. And that's where the vertex is going to be. 1, 2, 3, 1, 2, 3. And then I'm going to go 4 units, because 16 is under the 4. 4 units from center up and down. That takes me to the vertex on either side. So 1, 2, 3, 4. 1, 2, 3, 4. Because the center's at 0, 0, you are picking up the x and y intercepts. Now, best I can, connect the dots and try to round it a little. There's the ellipse. It's elongated. Because the number that's under the y is bigger, that says it is going to be elongated along the parallel to the y-axis. If it were under the x, it would be elongated parallel to the x-axis. And there are foci and all that kind of stuff, but we don't care about those.
Am I going to have to state which one is the major and which one is the minor?
No. We are doing a jector of conics. This is not in standard form, so the first thing I have to do is rewrite it in standard form. I need a 1 in that position. So to rewrite in standard form, I am going to have to divide everybody by 64. Now, when I first had conic sections, which ended up being, I think, my second semester calculus, these things got really nasty. But the good news is they don't get nasty here. So 4 over 64. So this is x squared over 16, I hope, plus y squared over 4 equals 1. Now you can see very clearly it's going to be elongated along what axis? The x-axis, because the number that's under the x is bigger. So the center is where? 0, 0. And when I look at A is, I'm always take it under that, so it's going to be the square root of 16, which is 4. And B is the square root of 4, which is 2. So that says from center along the x, I'm going to go back and forth 4 units. And along the y, I'm going to go up and down 2 units. So that says it's going to go this direction more than it goes this direction along the x more than along the y. So essentially it's going to be elongated along the x-axis. Now the x and y intercepts, by the way, the reason, even though I don't have to do these, the reason why I do is because when we come up with hyperbolas, which is the next conic that we study, then it makes sense as to how you know which direction things go. So if I look at the x-intercepts, well, this would say that x squared over 16 plus 0 squared over 4 equals 1, or x squared over 16 equals 1, x squared equals 16, or x equals plus or minus 4, so it's plus or minus 4, 0. Because the center is at 0, 0, we have them anyway. And then the y-intercept is going to be 0 squared over 16 plus y squared over 4 equals 1. Y squared over 4 equals 1. Y squared is 4. Y is plus or minus 2. So it's 0 plus or minus 2. Which we have anyway, because it's centered at 0, 0. So that says from center, which is 0, 0, I'm going to go back and forth 4 units. So to the right 4, to the left 4, and then I'm going to go up and down 2 units. I'm going to go up 2, I'm going to go down 2, and then we're going to connect the dots. And see, he's wider than he is tall, which is what you would expect. And we do have the x and y intercepts already.